Welcome at 30-1 to your first lesson on functions and relations. Now, in this lesson, we're just going to review what functions are, and to start off, we're going to look at polynomial functions. Okay? So, if I look at this here, a polynomial function is anything with more than one term. Poly and then nomial. Poly meaning multi. Now, I'm going to go ahead right here and we look at this here. It says, for example, the polynomial function 7x cubed plus x to the 4 minus 8x squared plus 5 has a degree of, well, what is my largest degree? 4. So it's a degree of 4. And a leading coefficient of, well, we have to go, the leading coefficient should be in front of your largest degree, which is going to be 1. Okay? And a constant term of 5. Now this constant term is also always your y-intercept. So let's continue to the next one here. It says, sketch each of the following functions and answer the question below. So when we take a look at this one, we're looking at 3x plus 1. What does that look at? Well, we know this is my y-intercept, which is right there. So we have 3x plus 1. And the 3 is my slope, so it's an increase like that. The next one has y is equal to 5. So this is going to just be, no matter what, y is equal to 5 on this one. So it's always going to look like this here, okay? So let's take a look at A. A says, state the domain for this one. Domain is all of my left and right values. So how far left does it go and how far right does it go? If I look at this, it's going to go forever left and forever right eventually, okay? So my domain is x is an element of all real numbers. Okay? Now let's take a look at my range. Well, if I'm looking at this, this will go forever up and forever down. So y is an element. We're looking at y such that y is an element of all real numbers. Okay? Next one here, where y is equal to 5. Now, this is just a constant. We might say there is an x here. It is x to the 0. Well, anything to the power of 0 is what? 1. So if x is 50, 50 to the power of 0 is 1. Okay? So that's 1 times 5, which is 5. If x is negative 1,000, negative 1,000 to the power of 0 is 1. So then x here, or y, 1 times 5 is still 1. So no matter what my x value is, my y value will always be 5. Okay? So, state the domain. Well, what is my domain? If we look at this, x goes forever that way, or forever that way, because we do have all these x values, because anything to the power of 0 is 1. So my domain is, we're looking at x, such that x is an element of all real numbers. Now let's take a look at my range. My range, we're looking at y. Well, now if I'm looking at y, my range here, can we ever go up or down? No. My range never changes. My range is always equal to 5. And that is it. Okay? Because it's a perfectly horizontal line. It's always 5, no matter what. Alright. Here we go. So now we're going to be looking at quadratics specifically. Okay? So when we're looking at quadratics, there's actually 3 styles of formulas, but here we're going to look at 2 formulas. We're going to look at general form and standard form. We also have factored form as well. Standard form is also called vertex form, as we'll find out later on. So here's my first equation. We have y is equal to x squared minus 3x minus 18. And it wants us to determine the zeros of the function, first by graphing. So I already have this nicely in my graphing calculator. Okay? And we are going to graph it. There's my graph. If we want to see, my window I put to negative 25. Why? My y-intercept is negative 18, and I looked at it, it's a happy face, so I'm going to have a minimum, okay, because this is positive. So I said it might go a bit lower, so I put negative 25. Now, we're going to go to my graph, and we are going to calculate my zeros. We'll calculate, and we want the zeros, okay? So, first 0 is over here. So we want left of the intersect. So there's left. Here's my intersect. Left would be this way of the intersect. Push enter. Now we want right of the intersect. So there's my intersect. Go right. That's right of the intersect. Enter. And I want a guess of where it is more or less. I put there, so I get -3. So one value is x can equal to -3. What's another one? Well, let's find my other 0. I'm going to calculate the other 0. So I push second, trace, 0, go all the way over. Go right there, enter. So that's left bound. Now we need to go right bound, so right of the intersection, there. And my guess is right there. So I get 6. So we have 3 and 6. Now it wants me to find my, move this over so it's clear. Now it wants me to find my y-intercept. Well, what is my y-intercept? My y-intercept is when x is 0, right? Because if I look at this line here on the y-axis, my x value is 0. So I'm going to trace 0, enter, which gives me -18. That is also my constant, okay? Next one right here, determine the coordinates of the vertex, okay? Oh, it also wanted me to sketch it, so I'll quickly sketch. Looks like that. This is -18, this is -3, 6. So we want to determine the coordinates of the vertex. So looking at this here, this graph is a happy face. I have a minimum. There's only so low we could go. Generally, the sky's the limit on what we could do. There's only so much we can't do, right? So there's only so low we could do, but the sky's the limit. We can only feel so low. There's a limit to how low we feel, but there's no limit to how good we feel because we're happy, we're positive. It's a happy face graph. Okay, so I'm going to hit trace. I'm going to calculate my minimum. There's a minimum. Left bound of the minimum, there's left. And I want right bound on my minimum. There's a right. And my guess is around right there. I get 1.5 and 20.5. So I'm going to change that to 3 over 2 and -81 all over 4. How did I get that? Well, I just multiplied this by 4 to get rid of the decimal, multiply this by 2 to get rid of the decimal, and keep it in fraction form. Okay, so it's over 4. So multiply by 4 over 4, and just multiply the top. Okay, so this is my vertex, is right there. Okay, so what is my domain and range? Well, first let's do my domain. My domain is all x values. Now this graph goes forever that way and forever that way. So my domain is x is an element of all real numbers. Now let's take a look, and we're looking at x such that, okay? Now let's look at my range. In my range, we're looking at y, right? Now, we look at this y here, and y cannot go less than this. So y is greater than or equal to -81 all over 4. And, oops, y is an element of all real numbers. Okay, so it looks like that. So we have -81 over 4, because that's the minimum it could be. Y has to be greater or equal to that. All right? Now the next one here says, use factoring to determine the 0. So let's factor this. So if I want to factor this, I'm going to use my trusty box method. So let's do my box method over here. And we have -18, and I'm going to have -3. So what two numbers multiplied gives -18? Well, I have 6 and 3. The negative must be bigger, so -6 and +3. So I end up getting x minus 6, and x plus 3 is equal to 0. So both those could be equal to 0. So I get x is equal to 6 and -3, right? So I'll make this equal to 0 or this equal to 0. Right? So let's try the next one. See, it says, rewrite this equation of the quadratic graph in standard form. So I want to put this equation into standard form. Let's try that out. So I have y is equal to x squared minus 3x minus 18. Okay? Now, in order to do this, to put into this form up here, I'm going to have to complete the square. So we half this and then square. So that's going to give me x squared minus 3x. Then we're going to go plus 3 divided by 2 squared minus 3 divided by 2 squared minus 18. Because if I add and subtract the same thing, what do we end up getting? Well, nothing. If I add it, I must subtract it, so the equation is the same. Now, I look at this here. That's the same as 9 over 4. So now I look at this. This part here, if I put this brackets on it, this is a perfect square. So I'm going to end up getting x minus 3 over 2 squared is equal to, and then I have to, subtract 9 over 4, subtract 18. Okay? So I continue this, and I'm going to end up getting, just put it that way, I'm going to get x minus 3 over 2 squared, okay? And then I'm going to have subtract 81 all over 4 if I combine that. Now if I look at this, notice my p and q, what do they equal to? This p value and q value, this and this, gives us my vertex. Okay? So that's kind of interesting. And we'll use that quite a bit to help us. Now let's look at example number 3. It says, using the graphing calculator, sketch the quadratic equation. So now we're sketching another one. So let's take a look at this. I have negative 3x squared, and we want to plus 4x plus 1. Let's try that again. Negative 3x squared, and I want to plus 4x, and I'm plussing 1, and I'm going to graph. And I want my window regular, so I'm going to zoom 6. There we go. So now it says use, so we have my graph there. Okay, I'm going to move this to the side so we create it. So it says use the features of the graphing calculator to determine the zeros of this function. So once again, features of the graphing calculator, we're going to determine the zeros. Oh, it doesn't look like that. So before I draw it, I'm going to find my zeros. So I calculate my zeros right here. So I go second calculate, and I want my 0. So left, right, guess, I get negative 0.22. So I have negative 0.22. So my 1 is going to be there at that negative 0.22. And my other one is, second calculate, find the 0, and we go left bound, right bound, guess. And I get 1.55. Okay? Now, it says, use the quadratic formula to determine the values of the zeros. So now we're going to have to use the quadratic formula here. So, if you remember, quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a, or all over 2a. So let's try and solve this out here. We have, my b value is 4, so it's negative 4 plus or minus square root of 16, 4 squared is 16, minus 4 times a, minus 4 multiplied by negative 3, multiplied by 1, which all over negative 6. So this is going to give me, we're going to have negative 4 plus or minus the square root of 28 all over negative 6. Okay? So now we could simplify this a bit more. We could take a 4. This could be divided by 4, which takes out a 2. So I'm going to left with negative 2. It's right here. This is 4 times 7. Plus or minus the square root of 7 all over negative 3. Okay? Or I could say divide those by that, so then it's just cancel off those negatives. So there is my answer. So I have the zeros at this answer there, and that is in exact radical form. Okay? Let's take a look at question number 4 now. So it says, consider the cubic function with the equation x cubed right there. So now we're going to use the graphing calculator for this one here. So let's put this in my graphing calculator. I want to clear that. What is my function? We have x cubed, so x to the power of 3. And then we want minus 8. And we have x squared plus 16x minus 8. And we're going to graph it. So there's my graph. Okay? So my graph, it's a cubic function. this. Actually, not quite. Very bad at drawing them. It's going to go like this, and then like that. Okay? Now, use the graph calculator to sketch the graph and the cubic function. So use the function to determine the x-intercepts to the nearest 10. So here, we're going to do the same thing again. We're going to have to try and find my x-intercepts. So all I'm going to do is second calculate and find my zeros for all three of those x-intercepts. And we'll end up getting 0.8, comma, 2.0, and we will get 5.2. So those will be my three x-intercepts, okay? So same idea, except here there's 3. Because as soon as it's a cubic function, we may have 0, 1, 2, or sorry, we'll always have 1, we could have 2, or 3 x-intercepts, all right? So we're always going to have at least 1. Whereas a quadratic, we could have 0, 1, or 2. Now we're going to look at the absolute value of a function. So if we remember back from before, every time we have an absolute value, if something's in the absolute value, that answer can't be negative, it just goes back into positive. Here's an example. Let's graph this here. X minus 2 is going to look like this, and then goes back up. Traditionally, it would continue going over, but instead, we push it back up. And at 2 is the intersection, okay? So what is my domain? My domain is x is an element of all real numbers. What is my range? Well, my range is looking at y such that, now I look at this here, y must always be, my function must always be greater than 0, such that 0, y is greater than or equal to always 0. And y is an element of all real numbers. Okay? So that's your absolute in general. Okay? And if you want, I could go over the piecewise functions with you tomorrow if you need help to remember that. Okay, let's take a look at radical functions now. Radical functions look a bit different. So here it says, sketch the radical function of the graph, 2x minus 1. So we want the square root of 2x minus 1. So it's going to look something like this. If I put in my graphic calculator, okay? Now it says determine the range of the function. So we want to know the range of this function. All right? Well, how did I get that? I'm going to say right here, we know that when 2x minus 1, 2x subtract 1, must be greater than or equal to 0. Because we can't square root a negative, all right? We also know then that x must be greater than or equal to 1 over 2 all the time. So right here, this part here is going to be 1 over 2. See how I kind of got that? And I leave it empty. It doesn't quite touch. Okay? So it must be, oh, it does touch, 1 over 2. Okay? Because we could have a 0, but nothing more. Now, determine the domain and range. Well, my domain is, we're looking at x, such that now x must be greater than or equal to 1 over 2. All right? Where x is an element of all real numbers. Now, my domain, or my range, we're looking at it right here, it's only going up. So my range, we're looking at y, such that y must be greater than or equal to 0. Y is an element of all real numbers. So that's my y. Okay? Hopefully you understood that. Almost done. So let's take a look here at the next one. We're looking at function notation. So remember, we have f of x. So there's my x values. Now it's saying instead of x, we have a 2. So we're going to have 2 squared. So it's like 2 squared plus 4 multiplied by 2 plus 5. Well, that's going to be 4 plus 8 plus 5, which is going to end up giving me 4 plus 12, 17. Okay? Let's take a look at the next one. Now it's saying 2 multiplied by all of that. So this here is just 2 multiplied by the whole function of x squared plus 4x plus 5. Okay? I multiply that in, I'm going to get 2x squared plus 8x plus 10. All right? Now we're saying we're replacing every x with 2x. So I have 2x squared plus 4 multiplied by 2x plus 5. So that gives me 4x squared plus 8x plus 5. Now, we want the whole equation, f of x, so the whole equation, and we subtract 2. Well, I'll move that down so we can see a bit better. So let's take a look at this whole equation, subtract 2. So we have here x squared plus 4x plus 5, and then we subtract 2, which is x squared plus 4x plus 3. The next one says we put x minus 2 in for the whole equation for every x. So we have x minus 2 squared plus 4, x minus 2, and then we plus 5. Now I have to expand this all out, which is going to give me x squared minus 4x plus 4 plus 4, and then we have plus another 4x minus 8, and then we go plus 5, which ends up giving me x squared plus 1. Okay? And the last one says we put in negative x. So let's put in negative x. So I'm going to end up having negative x squared plus 4 multiplied by negative x, and then we have plus 5. X squared minus 4x plus 5. All right? Now, here we're looking at expressions. So we have x cubed. Now, which expression is equivalent to the function? So match each function to the right expression on the left for the x cubed. So we have f of x. So we're putting x plus 5. Well, x plus 5 goes in for all the x in the x cubed. So this and this match. Now we have x cubed plus 5. I'm not sure what that one is. Now we have 5x. 5x goes in for there. And plus 5, that's this one. And next one, because look, we just added 5 to the outside, added 5 to the outside. That's all we did to the function. Next one is 5 cubed, so we just replaced 5 with x. Okay? There we go. Now we have absolute value in terms of function x. So now we're going to look at the absolute value. So here, we want this part here. So that's going to give me f of x subtract 4. So we're putting it in reverse. Okay? Here we have minus 4. That is, well, x is replaced with f minus 4. So it's f x subtract 4. Okay? Here we have 2 f of x. Because this part was just multiplied by 2. Next one, we have the 2 inside. So x is replaced with 2x. 2x. See how that's happening? This one right here, we have 3 minus. So it's 3 subtract, that's f of x. Because that there is f of x. Next one here, we have x is replaced with x plus 3. And then we minus 2. This one here, it's 1 over f of x. It's the reciprocal. And the last one is we just put in f negative x. X is replaced with negative x. And that is it. So we just look at how we're altering this and we put it in terms of f of x. Hopefully you understood all of this. If you have any questions, don't be afraid to ask me tomorrow as we work on this together.